So for this example, this is a pretty obvious square over here. Yeah, and how do we look at LPDR? Well, yeah, we're going to assess how good it is and depend on that, decide whether we want to change or alter our back square solution or not. So luckily for us, this last pair edge will actually be taken here and form like a base case, like F2L style base case with this corner, and then DR will actually be, be moved by the F to here, and L to D would not really change it. So we'll have DR here, the pair here, and so we can just pair up this pair with UR, and have the connected pair here with DR here, and we can use the common influencing pattern to insert the pair while influencing DR with the UF, U prime F. Yeah, so here's how we do it, F, L to F. So U, R, RY2, and then before we insert with an F, yeah, we influence DR like that. So that's one way we can do it, but then like in real solves, when I see this is right the edge for the front pair, and I would actually try to preserve its relative position because it's good, right? If we can kind of preserve it while we insert the edge, it'll be pushed to DF, and DF is a good position. Yeah, so let's see how we do that. We can do something smart here. We can do RY2B, RY2, yeah, to set up the back square, and then let's also check how it disrupts the other pieces. So the corner will actually stay unchanged, and same for the DR piece. Yeah, so we're getting lucky here. This is definitely a better solution than the previous one, especially as far as piece tracking goes. So let's just do that. And actually, before we do that, let's try to plan out LPDR in full. So we know that this edge will be pushed here, and it'll be correctly oriented. So the corner will not change, so we can solve it with U R prime F, and then DR will move to here, flipped, so it'll be R wide U R2, something like that. Yeah. So that U R prime F, R wide prime U R2, and before we insert the R2, of course, we can move on like that. Although I'm not gonna be focusing on second block because I can't really read white yellow. So we see that this edge is solved, and also this. So we're gonna, build two first blocks around these DL edges. So first off, around white orange. This is the the front pair. This is the back pair. It's probably easier to solve the back first because it also won't move around the front pair too much, and also it's short. And what's more, DR will be kind of fixed in here, which is a great place to be, because that means after we solve the back pair, the front pair, we can just do manipulations on RU layers without moving this, and then when we insert with an F. This will bring us up here to finish the influencing. So here specifically, I know this move sequence, we pair it up, and then we can insert like that. Yeah. So that's something we can do. And if we want to get fancy here, there's also this neat LPDR trick where, you do this, and then you kind of insert this with a keyhole, but instead of, inserting the corner like this, you would actually shortcut it like this. This will actually move DR here. Yeah. But this is kind of a rare pattern, so it's really okay whichever way you pick. I would probably actually prefer the first one because although it's longer, it's more straightforward for my fingers to remember how to move. Yeah, but there's that. And secondly, let's look at the other soft DL piece over here. Yeah, so this one has the back pair here and the front pair here. Again, it's a choice of which one we do first. And here again, it's pretty obvious because the back pair is only a 3 mover. The front pair is like a 4 mover and also moves, disrupts the back pieces a lot. So whereas this one, we can solve it more easily. So first off, there's this 4 move solution. Yeah, and the edge will not move, corner will move to here, which is totally acceptable. But also there's a 3 move solution, R prime U B2. Yeah. So So I basically then evaluate, what each of these options would, what kind of LPDR each of the options would give me. Yeah. So if we do this one, R prime, U prime, R U prime, um, well, it's actually okay, but you know this is actually okay. Yeah. So we can insert this pair with F prime, U prime, F. DR will be influenced to here, so that's actually fine. But what about this one, the three mover? If we do R prime U B2 from this angle, then actually this actually will be taken here. The corner will move to here by the R prime, here by the U, unaffected by the B2. So if we do a U, we'll have this pattern, yeah, and then DR will stay unchanged throughout this time. Yeah, so actually in both cases DR doesn't change, so it's pretty easy for us to you know uh, predict or track things anyways. So based on these reasons, definitely this back pair is the thing to solve, and whichever way out of the two is probably good, but I'm gonna use the second one because I think it's better, it's shorter. So R prime U, B2 U, R prime 2. Again, we'll take DR to here, and we can proceed with the rest of the solve. So for this scramble, we don't have a solved pair anywhere, but these two edges are pretty good because they're relatively solved. So we're trying to build the first block around that, excuse me. So here's the corner for the back square, and here are the pieces for the front pair. Yeah, so what we can do here is not that obvious, but I think it'll only become obvious when you kind of do the X rotation and start from there. So occasionally it's actually fine to start your FB with the rotation. So I would insert my corner with this, and notice this will actually affect our front pair nicely. Yeah, and all this time DR stays unchanged at UL, which is good enough actually. Well, because our FB is really smooth again, so there's no need to try to influence it anyway. Also, that'll mess up with our inspection. Yeah, so here I'm gonna show you this nice non-linear trick of solving the first square plus DR first, and then inserting the back pair, yeah, or the front pair. Yeah. So basically, here we see this pair already solved. The DR is actually can be solved together when we place it. Yeah. So like that, which means when I'm planning ahead, I would try to solve this front pair without affecting DR at all. Yeah, and what's good about that is, well, by fixing DR first and inserting last pair in an F2L-like style, we can limit the piece movement greatly and simplify second block tracking for us. So what I mean by that is that if you look at this is the second block square at the back, and it actually stay unchanged throughout our last pair solution because of how we decide to solve it without really affecting any of the second block positions, right? Because again, last pair is here, and we're solving it like that. Yeah. Notice we could have solved it without regard to pieces, blocks at the right. Then we could have solved it like this, but that's gonna be disastrous because it disrupts so many things. Yeah. So if we actually learn to solve LP without affecting DR, if DR is already solved, that will actually greatly simplify our second block tracking. Now we know, because now we know that the back pair actually stay there, and we can directly go ahead into solving the second square right afterwards. Yeah, so that's really neat, and this is like my most frequently used nonlinear block strategy. Whenever there is an easy first square plus DR, I almost always do it because I know that even when the solution is long, and the benefit in having an easier second block piece movement will simplify my life a lot, so that by the time I finish with FPDR, I most likely already know all the pieces for a second block, and yeah, and this just gives me a really fast second block because of that. So here's an easy first square. Now, however, this last pair plus dr is pretty awkward, so I'm going to show you a cool solution to that. Yeah, so if we insert it normally, we'd get something like this, R2b, RY2b. Notice that dr would actually be moved to here by the R2, and then again back here by the RY2. Now, how can we actually influence dr? Well, the idea is, before we do the second RY2, why don't we kind of limit the movement of the dr so that it does not, really get taken down by the R2, by the RY2. So what if we insert an M prime here, for example? Then when we insert it, dr will actually be taken here. And we do a B, U, R2. So yeah, this is how we do it a lot of times, by kind of canceling out some of the movement and then aligning dr to the correct orbit of a F or B layer insertion, by using the right amount of R moves or U moves. We can nicely influence dr to good positions, whereas if we do nothing, it could have been stuck, flipped in a really bad location. Yeah, so you would want to get familiarized with that if you want to get good at FBDR. And alternatively, there's something else you can do here. Prime. Yeah, again this. So if we stop being so smart, we can also do something like this. Yeah, so this is more like straightforward. You should be able to recognize this pattern. Yeah, again, we're about to do a B prime insertion, but right before we do that, we can insert a U. Yeah, dr will be taken here. So that's all I have for today. Yeah, if you guys find this helpful, let me know. I can make this into a fun series where I try to update this, more frequently, once every month or something. But yeah, please let me know your thoughts, feedbacks below, comment. I'll see you guys in the next video.